Hello again, I'm Mr. Steele. For the second time, I'm going to be working through one of the questions on the new Honors Pre-Calculus Quarter 1 and 2 Essential Skills Quiz model. In this video, I'm going to be focusing on the concept of linearity, but in the very narrow focus of writing an equation in point-slope form for a line that's provided to you in various different representations. So in this video, I'm going to start with just kind of a quick overview of the key ideas of linearity, the relationships that you kind of need to keep in your mind as you're diving into this question, and then I'll do the two questions that are directly off your ESQ model, so that way you can kind of work through them and hear sort of my thought process as I approach them. I would assess this question as being a pretty straightforward one. It's a really narrow focus of linearity. There's a lot more interesting and diverse questions out there about linearity that can and will be asked, particularly when you get to the calculus level where linearity is a huge idea from like Unit 2 onward. But I think this will give you a good foundation so that you can be really comfortable and move quickly through question 2 when you're working on your ESQ each week or whenever you take one in your class. So as mentioned, this is focused on linearity. Without further ado, I'm going to go ahead and begin. I will note if you want to navigate to a particular section of the video, there should be timestamps for all the chapters. You should be able to scrub to them as well. I'm taking advantage of YouTube's ability to do that. So in any event, I hope this video is helpful. Let's go ahead and jump in. So to kick things off, I wanted to do this for each video as best I can. I wanted to address a couple key ideas just to make sure that you're comfortable with them so that you have some background going in and sort of a foundation for the vocabulary if trying to watch some of the problem overviews or walkthroughs that I give here. If you're not sure what I mean or what I'm referring to, this can give you a sort of one-stop shopping outlet to get some of those key ideas in your head and to make sure we're using a shared vocabulary. So to kick things off, I wanted to start with just sort of the foundational relationship here. It's called the slope formula, and in a sense, it basically allows us to describe how lines behave. If you kind of think about it, like if we call this a line, this line is the same as this line, is the same as this line, except for one really key property. And that property is, what is its slope? Like how steep is it? Is it angled in a particular direction and orientation? All those things are really essential for us to be able to talk about lines and be able to qualify, describe, categorize, and of course, determine the equation of lines. So that's basically our first piece here. And by slope formula, I mean how do we calculate the slope if we're given multiple points on a line or a linear equation, however you want to think about it. And the relationship we're going to use is this one. M is equal to, got to make sure I write this correctly, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In a sense, what that does is it takes 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, x sub 2, y sub 2, and it allows us to translate into that quantity, that numeric representation of what we call slope. Basically, how steep is the line and which direction is it oriented. So basically, this formula is the literal slope formula. It takes those 2 points, which is what you're going to have in every problem for the ESQ for quarter 1 and 2 of Honors Pre-Calculus. But of course, you probably know this relationship just sort of with a different name, so it's worth pointing out some of those other names too. I think the most common one you might know this one is rise over run. Basically sounds like sort of a mantra for somebody who's into cross country. But setting that part aside for a second, rise over run is the same thing. It's basically how far you're going upwards in the y direction, hence y sub 2 minus y sub 1, over how far you're moving horizontally, which is x sub 2 minus x sub 1. There's also sort of a nice clean version of it, delta y over delta x, which points us towards some of the notation we'll eventually use in calculus. But for us, all these things are describing the same exact relationship. We're trying to represent how far something is changing vertically, or the rate at which something is changing vertically with respect to how it's changing horizontally. Hence that formula. So we're going to use the slope formula in every single question for problem number 2, the linearity question on this ESQ. You'll see how it can be represented differently, but it always does begin with 2 parts, or 2 points, which is sort of 2 parts. The second thing I want to address is the specific type or representation, I guess better put, of what our equation is going to look like here. We don't want you just to write the equation of the line because there are several different representations that are all sort of fair and perfectly fine in general. We want you to write in point slope form. And point slope form is the form that in calculus we're going to ask you to use pretty much all the time just for its clarity and simplicity and how easily it takes the information that defines a line, a single point and a slope, and captures that information in a linear equation. So it's important to know what point slope form is. What does that look like? And I'll just tell you straight up. It's y minus y1 equals m times the quantity x minus x1. And what this gives you is the equation of a line with slope m. So basically, specifically, its rise over run is going to be m. And it passes through, I'm going to use the drive-through spelling, through the point with coordinates x sub 1, y sub 1. And I do want to point out here that as you're looking at this, other than just kind of telling you you need to be able to, of course, like write an equation in this form to get this question correct each week, I want to point out that really this equation and this formula are literally the same things. Just to kind of point it out, obviously we have y2 and x2 over here, but if I wrote that m equals y minus y1 over x minus x1, if I wrote it in exactly that way, you can actually kind of see what's going to happen. In fact, I'll make it even clearer. If I put the equals m on the right side, I can multiply both sides here by x minus x sub 1. You're going to see it if you haven't seen it already. And basically these two will divide out, and you'll have y minus y1 equals m times x minus x1. So basically they're the same relationship. It's just we want this version, which is a function of x. Basically this is the variable, this is the independent variable, this is the dependent variable. We have an equation that generates a line. Like this produces a line for us. And so that's the form. This is what we expect you to actually generate your line and represent it as. Now having said that, it's worth just pointing out here, not that this question is going to ask you to do it this way, but just because you've used these forms before, I want to just quickly address what those other forms are out there so that you know what the difference is. One of those forms is known as slope-intercept, and I'm just going to abbreviate them really quickly since they're not our version. Slope-intercept form is your classic y equals mx plus b. The reason it's called slope-intercept is there's your slope, there's your y-intercept. Specifically, your y-intercept here is the point 0, comma b. So if you've ever wondered, like, why don't we use that? Just, it's because in the point slope form, we can see that original point. We can see the point that it goes through really clearly, whereas here we only see one specific point, and it's always the y-intercept, which may or may not be the point that we have or that we're interested in. So there you go. The other version, just so that we have it here for sort of completion's sake here, you could also have the standard form. And to be fair, I don't see this used all that often beyond where it sort of begins, but the standard form typically fits ax plus by equals some number c. And in a sense, this can be totally transformed into all the other forms by moving stuff around. In fact, I think you can kind of see the algebra or anticipate the algebra here. This is by equals negative ax plus c, and then divide everything by b. So in other words, this is, as all of them are, just another way of expressing a particular line's equation, but again, it's just a third version. Now, like I said, the green and the blue over here, standard form and slope-intercept form, those are not going to be what we're asking you for in question 2, but just to make sure you know the difference between those two and point-slope form, the one that we're interested in, I just wanted to address them. So there's kind of your quick hitting, said quick a bunch, there's your fast overview of linearity as far as you'll need in question 2 on this ESQ model. So with that said, let's look at the 2 problems that were given. And you're only given 2 because there's not a ton of variety that shows up on question 2, so we're not going to bombard you with a bunch of examples of the same effective thing each time. So our instructions here are pretty simple. They're the same no matter how the problem is presented to you, how that line's relationship is shown. It instructs us to write the equation of the line in point-slope form. So before I change my color here, let me just underline that for you. We have to write it in point-slope form. That's not an option. It's a requirement for this. And we're going to be given just some information. And no matter what that information is, we're always going to have some information pertaining to a line. And to define a line, we need 2 points. So in this case, we are presented 2 points. It's provided on a graph, but they just labeled the points for us. So in reality, as we want to dive in here, we are aiming to get to that point-slope form, which of course we just defined on the previous page as y minus y sub 1 equals m times the quantity x minus x sub 1. That is what is known as point-slope form. And for us to get that, we need to calculate or figure out what x sub 1 and y sub 1 are from the information provided, and then calculate the slope. Now, if you're kind of following this, there are 2 points here, so we will come back to that and how we choose which one or what we should choose as each one. But for now, let's focus instead on finding the slope. That's really our key relationship here anyway. That's the defining trait. Once we've got the slope, we're basically home free. So the question is, how do we calculate the slope? Well, once again, if you didn't watch the key ideas overview and you're not sure what in the heck I'm doing, I'd encourage you to go back to that section of the video and watch that. I overview all of these relationships, but if you've already got it or you just want to see me do it, of course the relationship we're going to use is called the slope formula. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the place we get that from is from the ordered pairs of the 2 points that we have on our graph, or really any 2 points we have on the graph, as long as they're unique. We need a first point, x sub 1, y sub 1, and we need a second point, which would be, of course, then x sub 2, y sub 2. So we just need 2 points. Well, good news, everybody. We have 2 points. So we're in great shape in this particular case. So over off on the side, again, I think you could probably just plug in from here, but just to kind of establish it, I'm going to go ahead and say that 4, 7 is going to be x sub 1 and y sub 1. And then I'm going to go ahead and say that the second point, negative 2, negative 3, is going to be x sub 2, y sub 2. Now, if you're worried because in your mind you're like, hey, what if I chose those in the opposite order? It's not going to matter. Basically, what would happen in that case is the numerator and denominator both have sort of a negative sign that could be factored out. You'd still get the same answer. You might just have to do a little bit of simplifying to get it there. No harm. It does not matter which one you choose first, as long as you're consistent with going the coordinates from each separate point consistently. So for us, we've got those pieces, so let's calculate out our slope. So y sub 2, it looks like here, is negative 3, minus y sub 1, that's minus 7. And our denominator, x sub 2, is negative 2. X sub 1 is 4. So we have negative 3 minus 7 is negative 10. Negative 2 minus 4 is negative 6. And I can go ahead and simplify that, both by dividing out the negative 1 and dividing 10 and 6 each by 2. We're going to get positive 5/3. And by the way, it's worth noting that our slope of this line is clearly positive. It's going upward. I was going to try to make the gesture, but doing it backwards on the camera confuses me. So it's definitely positive. We're in good shape. That's a good sign. That looks about right for what we were doing. So we now have our slope taken care of. The only thing that's left is to choose what our point's going to be. But the truth is, we have 2 choices for points. We could choose this as our point to plug in, or we could choose this as our point. Doesn't matter which one we choose, not in the slightest. So what I'm going to do is I'm going to be clever about this. Since I have a computer here that allows me to copy and paste, I'm going to go ahead and write our equation as y minus something equals our slope, which was 5/3, times the quantity x minus something. And then what I'm going to do is I'm going to go ahead and copy that exact skeleton and have a second one right down here. Because in reality, what we're doing is creating 2 possible versions of this equation. Like, there are an infinite number, but based on the points we have, we're just going to use those 2. So as far as what they can look like, I'm going to first use the top point up here, 4, 7, so that'd be y minus 7 equals 5/3 x minus 4. So there's one version of our equation. That represents the line we see up top. And then down below, we also have a good option. We have our second one, which uses negative 2 and negative 3. The difference is when we do y minus a negative 3, we can just go ahead and simplify that, to positive 3 and positive 2. I'm just going to go ahead and make that a little bit better. And voila. There is our first linear equation. Okay, the good news is if you can do problem number 1 from this section, you can definitely do problem number 2. In fact, I might argue that problem number 2 is identical to problem number 1. The only difference is that someone took your picture away. That's it. There's no more line drawing for you. Instead, you're provided the 2 points, and you're told the line goes through them. And our job is once again to generate the equation of this line in point-slope form. So I'm going to dive into this much more quickly because aside from the way the information is presented, there's nothing else different about this problem. If you have issues with that, I'd encourage you to go back to either the key ideas section or, of course, just watch problem number 1. It's effectively the same thing. So for us here, where I'm going to begin is by reminding myself really quickly of what point-slope form actually looks like. Remember, that's an equation that fits the form y minus y1 equals the quantity m, the slope, times the quantity x minus x1. So in order for us to do this, we need to calculate that point. Well, they gave us two of them, so I don't have to worry too much. More importantly, we need to calculate the slope. So for us to calculate the slope, that's going to be pretty trivial. We're going to use the slope formula, which is given by rise over 1, or delta y over delta x. But more specifically, since we're given 2 points, we probably will think about that as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And where those points are going to come from is by defining the 2 points that we have up top. So we have 5, 2 and negative 4, 7 given to us as 2 points on the line. And of course, 2 points do define a line in 2 dimensions, so long as they're not the same point, and they're not. So I'm going to go ahead and just call this x sub 1, y sub 1, and x sub 2, y sub 2, since we're sitting here. And I'm going to plug those into our point slope formula to get our slope for this line. Pretty defining trait. So y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. This is going to give us 5 over negative 9, which I would probably write as negative 5/9. Now, having said that, some people do sort of worry a little bit about potentially getting the order wrong. So in case you're stressed about that, what would happen if we flipped those 2 points so that instead this was x sub 1, this was x sub 2 and y sub 2 up top, and this was x sub 1 and y sub 1. Just so you can kind of see, this would become 2 minus 7 divided by, let's make sure I do this correctly, 5 minus a negative 4. This gets us negative 5 over 9, which is the same thing. It doesn't matter what order we go as long as we are consistent. So with that said, we now have our slope, so all that remains is for us to write out our equation. Well, good news there. Basically, everything about our equation is going to be identical no matter which point we choose. In every case, we're going to have negative 5/9 as our slope. Now notice again, by the way, it didn't ask us to do an equation of a line that was parallel or perpendicular. You know, obviously if it was parallel, it would look the same, but perpendicular would be different. Well, it would look the same. We'd have to find what other point it was on, but beside the point. For us, though, we do need to consider both possibilities as points. There are 2 correct answers for this. One of them would choose y2 and x2 and give us our first version of that equation. I personally prefer that one just because there's no change in the minus signs. Everything is pretty clean. But of course, we can choose the second one as well, where we have the minus 7 and the minus a negative 4. So in either case, you get the correct answer by using point slope form. And impressively enough, that is the end of this video. Basically, we've hit everything. We've done both examples. This is a pretty limited and narrowly focused question. It's all about the specific linear function skill of being able to generate an equation in point slope form. So just as kind of a quick little overview for you, as a reminder, we talked at the beginning about the slope formula, specifically that rise over run relationship that's so fundamental to linearity. We talked about the point slope form equation and also really where that comes from, like how it comes directly out of the point slope or point formula or slope formula. And then last but not least, we had introduced you to those other forms that linear equations in 2 dimensions will take, not because they're in this problem set or in this ESQ, but because it's valuable to know what the other options are so you don't get them potentially confused. So with that said, that's going to conclude everything in the video. I hope you found this helpful and informative if you were looking for a little bit of support with linearity as you dive into this ESQ. If not, I'm pretty sure that you're going to do line ever in any case. Okay, that wasn't funny. I'm just going to stop the video. Thanks for watching. So long.